There are 7 circle theorems that you need to know about. These are some of the most frequently occurring types of exam question. Pupils tend to find them really difficult, but that's often due to lack of practice. So in this clip, we're going to make sure we do them enough to be able to remember them. Let's look at this first one. When a radius meets a tangent, the angle that it makes will always be 90 degrees. Obviously, this works for diameters as well. Using this circle theorem, try to answer this question. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I spotted that there's a right angle here of 90 degrees, and then there's a triangle which must add up to 180 degrees. This second circle theorem is also fairly straightforward. From a point that's outside the circle, 2 tangents can be drawn. From the point to where they touch the circle, the tangents will be equal in length. Can you now use this fact to answer this question? Press pause and have a go. When you're ready, press play. Here's the answer. You should have spotted that because the tangents are equal in length, we have an isosceles triangle, so this angle here is 40. We then know that the angles in a triangle must add up to 180, and this gives us the 100 degrees. Now let's move on to the third circle theorem. The angle subtended at the centre of a circle is twice the angle at the circumference. Subtended just means made. So in other words, the angle here is double the angle here. Now when it looks like this, it's fairly easy to remember and easy to spot. But sometimes the questions might look a bit different. These 3 diagrams here all show the same situation as this, just in different ways. So here, this angle will be double this angle. If we move this point round the circle a bit, we get this picture. And this angle is still double this one. This one here is the hardest to spot. We've still got an angle at the centre here, and it's still going to be double the angle at the circumference. Now use this theorem to answer this question. Press pause and have a go. When you're ready, press play. Here's the answer. You should have spotted that this will be double this. Now we're ready for the fourth circle theorem. The angle in a semicircle is a right angle. This just means that if you put a diameter anywhere on the circle and make a triangle that touches the circumference, you'll always get a right angle. Now here's a question involving that circle theorem. Press pause and have a go. When you're ready, press play. Here's the answer. You should have used the circle theorem to realise that this is 90 degrees, and then we've got a triangle which must add up to 180. Now for the fifth one. Before we look at the circle theorem, I just want to quickly revise what segments are. If we draw any chord on the circle, we make 2 segments, one here and one here. What the circle theorem says is that angles in the same segment are equal. What this means is that if I draw my chord here, I've got 2 angles here that are in the same segment, and they will be the same as each other. Using the same diagram, we can turn it upside down and draw the chord here and get 2 different angles that are still the same as each other. Or you might even have a situation where you've got 3 angles coming off the same chord. They're still going to be the same as each other. Now try this question using that circle theorem. Press pause and have a go. When you're ready, press play. Here's the answer. You should have spotted that we can draw a chord here, so these 2 angles are in the same segment, making them the same as each other. Now for the 6th circle theorem, and this one's a tricky one. This one's called the alternate segment theorem, and just like the last one, it uses segments. If you draw a tangent to a circle, and then draw any chord that touches that tangent, you make an angle here. Now this angle is in this segment of the circle. The angle in the alternate segment, which is this one over here, will be equal. We can also look at this same diagram in a slightly different way. If we look at this chord with the tangent, we've got this angle here, which is in this segment. This angle is in the alternate segment, and it will be equal to this one. We still have a tangent and a chord making an angle, and the angle in the alternate segment will be equal to it. Don't forget that the tangent doesn't have to be horizontal to make this work. Now try this question. Press pause and have a go. When you're ready, press play. Here's the answer. You simply need to spot that this is the angle in the alternate segment to this one. Finally, we're going to look at the last circle theorem. This one tells us that the opposite angles of a cyclic quadrilateral add up to 180 degrees. A cyclic quadrilateral is any four-sided shape drawn inside a circle where the corners all touch the circumference. Two angles opposite each other add up to 180, so we have one pair here and one pair here. Sometimes it's a bit harder to spot. This is still an example of a cyclic quadrilateral, so we'll have a pair here adding up to 180 and another pair here. Here's a question on that one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. To get this one, you needed to take 78 away from 180, and to get this one, you needed to take 75 away from 180. Now we're going to look at lots of different exam-style questions on circle theorems. You need to spot which circle theorem it is and use this to answer the question. Sometimes you'll be asked to give a reason, in which case you can state the circle theorem. Sometimes you'll be asked to show your working. If this is the case, make sure you do it methodically. You might find it helpful to sketch the diagrams. When I go through the answers for these, I'll just be showing you one way, but there's often more than one method to get the right answer. Here's your first exam-style question then. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you. Press pause and have a go. When you're ready, press play. Here's the answer. For part A, you needed to realise that this angle here will be double this angle here, making it 140 degrees. For part B, you should have realised that because this is 140, this will be 220 because we've got 360 degrees here. You then know that the four angles inside a quadrilateral add up to 360